Hey guys, today we're going to start looking at multiplying polynomials. Remember, polynomial, that's just a fancy word for an expression. So before we do that, well actually we can go ahead and get into it, but I do want to remind you of a strategy we've used before. So this will be our first example. When you see this, the first thing I want to remind you of is if there's no symbol between a number and a parenthesis, that means multiply. And the strategy that we've used for quite a while to multiply is the distributive property. Well, we're going to use that here as well. So 5 times 1x is 5x, and 5 times 8 is 40. So this simplified expression or polynomial is 5x plus 40. Just a reminder, this is a binomial with a leading coefficient of 5. So let's keep going. For our next example, we're going to do negative 5 times x squared plus 2x minus 8. I do want to remind you, make sure you multiply everything in the parentheses by negative 5. So first, negative 5 times 1x squared is negative 5x squared. Negative 5 times positive 2x is, oops, I almost put positive, negative 10x. Negative 5 times negative 8 is positive 40. Now let's take a look at something that looks a little bit different than what we've done before with the distributive property. So now I want you to notice I have a variable outside of the parenthesis. Well, we still do our numbers or our coefficients as normal. So I'm going to say 3x times 9x, 3 times 9 is 27, but when you're multiplying variables, you add the exponents. So I have x to the first here, x to the first here, so x times x is x squared. Let's keep going. 3x times negative 2 is, 3 times negative 2 is negative 6, and I have one x on the outside, so that becomes negative 6x. So our simplified expression or polynomial is 27x squared minus 6x. And I also want to give you some more terminology that you'll hear. You'll also hear, instead of simplify this expression or polynomial, you might hear what is the product, because remember, a product is an answer to a multiplication problem. But you also may hear, let me change this, you also may hear what is, or write an equivalent expression. That means the same thing. Do the distributive property. So let's try this next one. 4x squared times 5x minus 1. So 4 times 5 is 20. I have two x's on the outside, and remember that's x to the first. So x squared times x is x to the third. Now let's multiply the next one. 4x squared times negative 1, that's negative 4. And I have x to the squared and no other x's, so I just leave it x to the square, x to the second power, or x squared. Let's do one more like this one. Sometimes they use different variables, which is perfectly fine because we've learned that they use the letters or variables that are in context or that represent different things in the problem. So let's do negative 3 times 7L is negative 21L, and negative 3 times negative 7 is going to be positive 21, and there's a W there. Okay, that's a 1, not an L. Same thing here. All right. So that's how we multiply an expression by a monomial. That's what that, if you look at that, that's what this set of problems has in common. Now let's step it up a little bit. Sometimes we will multiply two binomials. Now, first of all, we can still use the distributive property here, okay? I can multiply everything by 4x. Okay, I'm going to go ahead and do that. 4x times 1x is 4x squared. 4x times 9 is positive 36x. And then I'll multiply everything by -1. You just have to make sure that you do everything here, okay? -1 times 1x is -1x. -1 times 9 is -9. And then you'll combine all your like terms, okay? I don't see any other x squared, so 4x squared. 36x minus 1x is 35x. And then bring down the -9. So that is a way to do this. Just distribute each of the terms, like 4x, multiply everything in the second parentheses, and then the second term in the first binomial. I hate to use all that language, but that's what it's called. Multiply everything in the second binomial. I want to show you a strategy that you can use that is used in the math world called the FOIL method, okay? This is specific to multiplying two binomials. And FOIL, F-O-I-L, means I multiply the first two terms, the outside two terms, the inside two terms, and the last two terms. And that gives me, of course, you combine like terms, and that gives me my answer. So let me show you how to do it with this same problem. So I'm going to rewrite 4x minus 1 times 1x plus 9. And I'm going to say FOIL as I do it. First, so my first two terms are 4x, and I'm going to write it out for this one. 4x times 1x, which is 4x squared, okay? Outside, which is 4x times 9, which is 36x. Inside, which is -1 times x, which gives me -1x, times plus my last, which is -1 times 9, which is -9. And then I'm still going to combine that 36x minus 1x to get 4x squared plus 35x minus 9. Notice you get the same answers as you do if you do the distributive property. Now, for the rest of the lesson, I'm going to use the FOIL method to simplify multiplying two binomials. So let's take a look at number 7. I'm going to multiply x minus 2 times 2x plus 2. So I'm going to use FOIL. First, x times 2x is 2x squared. Outside, x times 2 is plus 2x. Inside, -2 times 2x is -4x. Last, -2 times +2 is -4. And I do have like terms to combine, so my equivalent expression or simplified answer or product is 2x squared minus 2x minus 4. Number 8, let's multiply a couple more binomials. So -8x plus 3 times 4x minus 5. Since I have two binomials, I'm going to use my FOIL method. I'm going to multiply first. -8x times 4x is -32x squared. Outside, -8x times -5 is -40x. Inside terms, 3 times 4x is plus 12x. Last terms, 3 times -5 is -15. And I do notice that -40x plus 12x can simplify. So I have -32x squared. And then I have -40 plus 12 is going to give me -28x minus 15. So my simplified expression or product is -32x squared minus 28x minus 15. Let's try one more before we go into our last set of problems. So I have 4x minus 2 times x plus 2. I'm multiplying two binomials, so I'm going to use the FOIL method. Multiplying my first two terms, first in the set of parentheses. 4x times 1x is 4x squared. Outside, 4x times 2 is positive or plus 8x. Inside, negative 2 times 1x is negative 2x. And last, negative 2 times 2 is negative 4. I do have like terms to combine, so I'm left with 4x squared. 8x minus 2x is positive 6x minus 4. So this is my simplified product. Now let's take a look at our last type of polynomials that you may have to multiply. So I want you to write x minus 9 in parentheses, and then we're going to square that. Before I show you what that does mean, let me show you what it doesn't mean. That does not mean I distribute through that 2 and get x squared minus 9 squared, which is 81. That is not correct. Here is what it does mean. When you have a binomial like this that is squared, let me rewrite that. That means you rewrite it like this. X minus 9 times x minus 9, and then you use the FOIL method or distributive property to multiply. So first, x times x is x squared. Outside, x times negative 9 is negative 9x. Inside, negative 9 times 1x is negative 9x. And last, negative 9 times negative 9 is positive 81. The middle two terms simplify. X squared minus 18x plus 81. So let's try a couple more that look like this. So first we have 9x minus 4 squared. Remember, this means to rewrite it as 9x minus 4 times 9x minus 4. And then we're going to use our FOIL method to multiply. First, 9x times 9x is 81x squared. Outside, 9x times negative 4 is negative 36x. Inside, negative 4 times 9x is again negative 36x. And last, negative 4 times negative 4 is positive 16. Do I have like terms to combine? Yes, I do. So I'm left with 81x squared plus, I don't know why I said plus, probably because I add them. So negative 72x plus 16. So this is my equivalent expression. Again, hear the way I say this. This expression is equivalent to this one. This expression is the product of this one. Or you can say this expression is this polynomial simplified.